Here the question asked is, let an be the sequence defined by an equals to greatest integer box n square plus 8n plus 18 upon n plus 9, where x denotes the largest integer which does not exceed x. Find the value of summation from n to 1, from n equals to 1 to 30 an. In this question we are given the greatest integer. uh, for greatest integer we must know that the function greatest integer, this value gives the uh, small if in place of x, if there comes a integer, then the result will be integer. And if the result will be if result is in decimal or in fraction, then the value will be just a smaller integer. For example, let's us take integer. Integer 1 equals to 1, integer minus 1 equals to minus 1, integer minus 100 equals to minus 100. Similarly, integer 2 equals to 2. So when we give input as integer, then output will be integer. But in case we if we provide a decimal number like 1.2, then result will be 1, smallest value. Just smaller than 1.2 is integer smaller than 1.2 is 1. For example, also 1.9, a small integer less than 1.9 is 1. If we go for 2.1 to minus 5.6, which is the just a smaller integer than 5.6, minus 6, minus 6.1, minus 6, no, minus 7. Integer just smaller than 6.1 is minus 7. You can see in this line graph here minus 1. Similarly, when we come we get minus 6 and minus 7. Then 6.1 lies over here. Then a smaller integer than 6 minus 6 point is minus 7. Yeah, so in this way we came clear about this greater function. Now we resolve this function as in this way. Now we try to resolve this function in this way: n square plus 8n plus 18 into n plus 9. We should try to maintain, to eliminate as soon as possible as this n plus 9. So in order to maintain this n plus 9, we factorize this numerator as n square. This 81 is provided, we need 9n, so 9n. In order to balance this, we write over here n. Now it became 80n, and then again minus 9. We write minus 9. After minus 9, we have to again plus 9 plus 18. This became n square n common n plus 9 minus 1 common n plus 9, 27 whole divided by n plus 9. This expression became n minus 1 we took common, and n plus 9 plus 27, and this n plus 1 9 and n plus 1 9 will eliminate itself, and this fraction, this part became n plus 9. N plus 9 is over there, so this became n minus 1 plus 27 upon n plus 9. This is now an becomes this. Here an equals to, we can say an equals to n minus 1 plus 27 10 upon n plus 9. N minus 1 27 n plus 9. Now look at this value. For this value, if we take 1, then what we get? 27 upon 1 plus 9, which gives 27 upon 10. This will be 2.7. In same way, if we go to 2, then 27 upon 9 plus 2, this gives 2.45. Similarly, if we go furthermore and go through up to 10, then what we get? 1.42. And this greatest integer is 2. Here greatest integer is also 2. So up to when our greatest integer is here in 10 our greatest integer become 1. So when n equals to 18, this became 1, and from 19 on forward our greatest integer will be, this is our greatest integer, this is our greatest integer, and from 19 and from 19 onward this became 0.96 on 19. So our greatest integer will be 0. So from 19 on forward our greatest integer becomes 0. So we can write this for this expression. We can write like this: if n is less than up to when 18, from where 1 to 18, we get our greatest integer maximum as 2. This value became up to 2 and minimum up to 1. And for n greater than 19 or equal to 19, our greatest this 27 upon n plus 9 lies between 0 and 1. this value is nearly approaches to 1, so this is less than 1, and the value of this function is always greater than 0. Value of this function is always greater than 0 in range what? N equals to 1 up to 30. So now we can write an as n minus 1. Now 27 upon n plus 9 becomes n so now this expression became n plus 1. For n ranges from up to 18, 1 to 18, and then from now the expression then Sn becomes n equals to 1 to n is to 18, n plus 1, and then from 19 onward to 30, this expression became n minus 1. Now we can break this expression like that. Summation n equals to 1, 18 n plus summation n equals to 1 to 18 plus 1 plus summation 19 to 30 n minus never try to maintain a mistake like cancelling these two terms. Here you can see plus 1, but look at this limit, minus 19 to 30 and 1 to 18, so this term will never cancel each other. Now 1 to 18 and 19 to 30, then this term become n to 1 to 30. This term we solve for these two terms, and n to 18, this term became how much? This term became 18 minus 1 plus 1, and this term became upper limit minus lower limit plus 1. And now from 1 to 30, this sum of natural number is n into n plus 1 by n plus n. This we know formula for first n natural number, and this became this will cancel each other, and 18 and 30 minus 19 plus 1, we got 12. This is for 30, then 31 into 30 by 2, 18 minus 12, 6, 15 into 31 plus 6, and then 31 into 15 plus 6, we got 471, which is our final answer. 471 is the final answer. So at conclusion, we can write, in conclusion we can write 471 as the our answer. Thank you for watching.